Good
Good
day,
day,
viewers,
viewers,
and
and
you are welcome to solve this exponential equation. Given that 3 to the power of x equals x minus 1 to the power of 2. To get into this, and what we are going to apply here is the principle of Lambert omega functions. That is what we can use to solve this. Because if you have omega of a exponential of a, this gives a. That is, we take this coefficient of this as the value when we plug this in this function. But how can we do this? So the first thing we are going to do is we take the square root of both sides. So by doing that, we have 3 to the power of x in root equals the square root of x minus 1 to the power of 2. Then we write this as 3 to the power of x divided by 2 equals the whole of this, which is root of x minus 1 to the power of 2. It is given as absolute of x minus 1. And the absolute of x minus 1 here, we can have it as either x minus 1 or we have it as 1 minus x. And for these equations, this x minus 1 will not satisfy this, and we are going to work more on 1 minus x. Alright, we have 3 to the power of x over 2 equals 1 minus x. So I'm looking at these two sides. Suppose I let this one to be f of x and I let this one to be f of x. By graphing this 3 to the power of x over 2 is an increasing function, and with this as well. So we cannot call this one increasing function because when we plug different values like a real number value, so we might get the negative values. Alright, so by graphing these two, we have something of this nature. So this 3 to the power of x over 2 that is increasing, so we're going to have it like this, and for 1 minus x, we have it like this. So to cut the story short, what I'm trying to explain here is there is no any relationship between them, which means they don't meet at all. So let's now see the value that is satisfying this problem. So by dividing both sides by 3 to the power of x over 2, we have 1 equals 3 to the power of minus x over 2 bracket 1 minus x. And by rewriting this equation, we have 3 to the power of minus x over 2 bracket 1 minus x equals 1. So our goal is to get this in form of this Lambert omega function, that is anything we have at the back of this exponential must be the same as power, and we haven't get that. So to get that, we are going to multiply this equation by 3 to the power of 1 over 2. So we have this as 3 to the power 1 over 2 multiplied by 3 to the power of minus x over 2 bracket 1 minus x equals 3 to the power of 1 over 2. And with this, we have the same base, different power, which means we add this together, and we have 3 to the power of 1 minus x over 2 bracket 1 minus x equals 3 to the power of 1 over 2. And the next thing is, here is 3 to the power of 1 minus x over 2, and we have this as 1 minus x, which means we need to divide both sides by 2. So dividing both sides by 2 here, so which means the power of this is now the same thing as what we have here. So we will write this thing properly as 1 minus x divided by 2 multiplied by 3 to the power of 1 minus x over 2 equals 3 to the power of 1 over 2 divided by 2. Again, this 3 to the power of 1 minus x over 2, we introduce exponential and ln to this. And we have 1 minus x over 2 multiplied by exponential of ln 3 to the power of 1 minus x over 2 equals 3 to the power 1 over 2 multiplied by 1 divided by 2. And so what is missing here is ln 3. So when we transfer this 1 minus x over 2 to this back of the ln, and the only thing that is missing here is ln 3, which means we multiply ln 3 throughout this. And here we have 1 minus x divided by 2 ln 3 multiplied by exponential of 1 minus x divided by 2 ln 3 equals, here we have 3 to the power of 1 over 2 multiplied by 1 over 2 ln 3. So we can now introduce the function which is w to both sides. So by doing that, we have the omega of 1 minus x over 2 ln 3 multiplied by exponential of 1 minus x over 2 ln 3 equals, so with this as well, when we introduce omega to this, so here is 3 to the power of 1 over 2. But I want us to know something here, that this 1 over 2, I can take it to the power of this ln 3, and here we have ln of 3 to the power of 1 over 2. So here we have already chosen 1 minus x over 2. Here is ln 3 equals, but trust me, for this one as well, we can make this one looks like when we plug it in a omega function, which is Lambert. So what we are going to do is, if this is omega of this ln 3, suppose it comes here as ln 3 to the power of 1 over 2 multiplied by, when we introduce exponential and ln to this 3 to the power of 1 over 2, we have exponential of ln 3 to the power 1 over 2. So which means that what we have here is the same thing as what we have at the power of this exponent, and we take ln of 3 to the power of 1 over 2. Alright, so here is 1 minus x over 2, and we have this as ln 3 equals, so when we take ln of 3 to the power 1 over 2, we are going to take this 1 over 2 to the back of this, and we have 1 over 2 ln 3. So if ln 3 cancelled ln 3, we have 1 minus x divided by 2 equals 1 over 2. And suppose 2 cancelled 2, we have 1 minus x equals 1, and which the value of x here equals 0. Wow, can't we just guess from the beginning that the value of x here equals 0? So and that is the power of the Lambert omega functions. So if we guess that this is the equals this x equals 0 from the beginning, so and we need to know how it works as well. So thanks for watching, and don't forget to subscribe to this channel for more exciting math content like this. I will see you in the next video. Never stop learning. Bye bye.